Topics covered in Chapter Polynomials. Welcome to our chapter on polynomials. We will begin with a fundamental introduction to the essential terminology, such as terms, coefficients, and degrees, and learn how to classify different types of polynomials. Next, we will explore the geometrical meaning of zeros, learning how to identify them as the x-intercepts on a Cartesian plane. Finally, we will examine the algebraic relationship between the zeros and the coefficients, specifically for quadratic and cubic polynomials. Understanding these core mathematical concepts is vital, as we will later see how they are applied to solve complex problems in real-world fields like physics, economics, and engineering. Real-world applications of polynomials. First, in the field of physics, quadratic polynomials are essential tools for calculating the trajectory of projectiles and understanding motion under the influence of gravity. Moving to economics and business, polynomial functions are frequently employed to model trends in cost, revenue, and profit. This allows analysts to predict market behavior and determine the most effective strategies for optimizing pricing. Lastly, in engineering and computer science, polynomials play a vital role in curve fitting, signal processing, and the development of complex three-dimensional graphics. In these fields, they ensure that all digital surfaces and paths are smooth and mathematically precise. Now that we have explored the fundamental properties and the geometric meaning of polynomials, let's discuss why these mathematical concepts are so important in the real world.